Have you enjoyed lunch? We're about to start the second phase of today's event and the third session, where we had very interesting presentations in the first two sessions. Now it's time to go a bit closer to the industry, to understand different challenges that they face, how we're addressing these challenges using state-of-the-art technologies, possible use cases, how we're using EU funding and specific projects in order to produce real value to the industry. We're going to focus in three main industries: manufacturing industry, process industry, and mining. So we're going to have three different sessions, panel discussions that are going to be led by our own, three of our mission leaders in the company. So without further delay, I'm calling, please, Dr. Pantelis Papachristou is coming on stage. So he's the mission leader of the Digital Twins mission in CORE. So, Pantelis, the floor is yours, and please call your panelists.
Thank you, and please, the speakers, if you want, please join us on the stage. Okay, so Pedro, if you would like to join, thank you. So welcome to this first panel of the third session of Core Innovation Days. My name is Pantelis Papachristou, and I'm leading the Digital Twin unit in Core Innovation Center. Today, I have the privilege of moderating this discussion on digital and green transformation of manufacturing. In this panel, what we aim to explore is how digital and green technologies are reshaping manufacturing ecosystems, identify challenges and opportunities, and discuss the role of innovation, data, and AI collaboration in driving this change. I know that just right after the lunch, statements like this may sound a bit hard to digest, but please don't worry. We will focus on practical applications and examples from European research and innovation projects. Before we get into the specifics, let me start with a question to you first. I want you to think, how do you imagine the future of manufacturing? Is it smarter? Is it greener? Is it more connected? And also, how far do you think we are from there? Is it decades, years, or is it happening just right now? Joining us today, we have 5 distinguished experts who are actively involved in this transition, bringing unique insights from European projects that are shaping global manufacturing. We have with us today Professor Pedro Malo, co-founder of Unparallel, where Unparallel provides digital technologies and consulting services on digitalization. Professor Paolo Petrazzoli, partner at TTS, mainly focusing on simulation of manufacturing systems. Dr. Dimitris Panopoulos, and also a former a teacher of mine in the Technical University of Athens, COO at Suite 5, where Suite 5's mission is to deliver intelligent, data-driven solutions. Dr. Nikki Kusi from EIT Manufacturing, Managing Director at EIT Manufacturing Southeast, whose mission is to foster synergies and innovation in the regional manufacturing network. And Dr. Vicky Panagiotopoulos, Research Engineer at LMS, the Laboratory of Manufacturing Systems and Automation of the University of Patras. Thank you all for being here today. I also invite you to be active participants in this discussion. Following the personalized question to our speakers, we will have dedicated time for you to ask questions or make comments to our speakers. So, Pedro, let me start with you first. Yes, is it okay? Yeah.
Is it working? Okay.
Perfect. So, in the emerging manufacturing landscape, data seems to become the most valuable resource, or we can say the backbone of modern manufacturing. As manufacturing systems grow increasingly complex, adapting standardized and common communication protocols can boost interoperability, like the asset administration cell concept. So based on your vast research on this area, how can this asset administration cell concept contribute to this direction?
Okay, thank you very much for hosting us. Actually, very nice event, nice people here, nice to meet you. So I'm here because I have a company that is doing digitization. I'm also a professor, and I did a PhD in interoperability. So I tend to have a lot of time working on these matters of interoperability, data, and complex systems. Actually, the AS is an interoperability enabler, right? So this is that. I will divert from talking more about the AS because it was already presented in a session by the colleague of Ayman. But if you remember, if we start, if we recall, where is this problem of interoperability started? If we all remember, it started in the Genesis book, where with the Tower of Babel, when the humans wanted to reach God, and they wanted to create a city and then a tower to reach God, right? So, and then God says, no, 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 impossible. I will put everybody talking different languages, spread the people around the earth. And this is how, well, it's not as it started, but most probably, if we believe in this parable, it started there. And since then, we've been dealing with the problem of interoperability, right? And maybe the best way that I found that is still correct to solve the problem in a way that really works is about having standards, agreeing on things, even if it's minimal. And we've seen that. I've been working a lot on this in this area, many projects, and all of them, all of the calls, the topics talk about interoperability. Maybe it's the best topic to work because it will never be solved, because people invent solutions, semantics, whatever, knowledge graphs, everything, and possibly the solution that makes sense is standards, right? And the AES does exactly that. I also work with the IFC. I didn't talk with the colleagues of IMN, but I started in the IFC model. IFC is Information for Construction. Actually, it's called Industry Foundation Classes. I was part of that process. I built part of that model. And I saw what it happened, what it changed the industry, the construction industry with that model. And the impact that it was made was profound. And if we see, like, for instance, Apple, big ones are very strong on standards. Actually, if you go online, you see that Apple is most probably one of the biggest organizations doing standards, involved in many committees of standardization. And interesting that Europe was mandating for the USB-C, right, for the phone, and we cannot agree in Europe for a plug for electrical charge, right? If you go to Italy, you have a plug. If you go to France, another plug. Portugal, another plug. But we mandate the USB-C in the chargers. We are a bit. This is Europe, right? Anyway, Tesla the same, right? Tesla is very on standards and manufacturing. Maybe they are the prime on manufacturing now in the world. And it's interesting that the charge plug, if it's industry-led, it works, right? Because they created a plug for charging the electric cars. And the other competitors said that, okay, this is the best, let's not do another, because it's good, right? And now General Motors is using it, and others are also using it in the US, and we still are discussing in Europe as usual, right? And we will, of course, adopt Tesla because it's the best. And so standards are industry-led, that people agree because it makes sense, not because we are pushed, it works. And I think AES is an enabler for that to happen, okay? Just two more notes, fast notes. Two projects that we are working on which AES is being used. So we are using it, for instance, in a project on digital product passports, but evolving it to services, so including the service dimension there, which is not accounted. So we are doing AES-based DPP, but also including the service dimension for life cycle and circular manufacturing. And another one which we are putting AI, embedding AI into the AAS to creating a bit of cognitive AAS, which we bring not only the data up, but we are able also to, inside of the AAS concept, to create intelligence and develop a bit more things. So it makes sense, and we are evolving the concept and applying more, and I think it makes total sense to explore this concept a bit more. Okay? And it's an industry thing that came from Europe, by the way. Yes. Right? AAS is from IDTA, from Industry 4.0 German thing, so it's nice. Sometimes we do nice things in Europe also. Thank you. Sorry.
Thank you, Pedro. Thank you. Let's hope that the AAS will solve this communication problem, not like the long-standing Babel problem. I think it will be much faster at that time. Let's see. I come to you, Dimitri, now. Yes. Okay, data seems to be the most valuable research in modern manufacturing, but artificial intelligence serves as the driving engine, powering every aspect of production, from design and development to manufacturing and logistics. Based on your expertise, how can AI-driven tools and toolkits support circular manufacturing systems, as demonstrated, for example, in projects like Circular Twin?
First of all, thanks for inviting me here, and congratulations for organizing this day. It's first time in Greece that a partner of us or a company like yours has made it to organize such a nice event. So congratulations, and I hope that there will be more core innovation days in the near future. Now, regarding your questions. Undoubtedly, data is the foundation of Industry 4.0 and beyond. Every device, every sensor, every human-machine interface produces vast amounts of data. Till now, till a few years ago maybe, taking advantage of those data was, let's say, limited to some basic statistics or to getting some nice dashboards. Now, people in the industry have started to realize that AI, artificial intelligence, is actually the only mean we have, the best way to take advantage of those data and translate them to action insights. Not only to optimize production processes, which is something that we understand, but also to facilitate sustainable material flows, reusability, resource allocation, everything that has to do with circular manufacturing and the concepts that are hidden behind circular manufacturing. As you said, as Suite 5, we have participated and technically coordinated a number of projects like Circular Twin, X-Man AI, AI Regio, and more, consistently serving as AI experts. So a few years ago, we didn't have the experience from the manufacturing sector. We got into this sector as AI experts, and we tried to gain hands-on experience on what are the challenges, and after understanding what the challenges are, to provide solutions, AI-based solutions. Through our participation in the project, but also through some commercial projects that we have implemented, mainly having as clients partners who were partners in research projects that decided to further invest in order to receive commercial services from us. We identified that there are, let's say, 4 key AI-driven capabilities. First, it's process optimization, intelligent process optimization, adjusting production parameters in real time, leading to reduced energy consumption and material waste, and of course, improved throughput. Secondly, predictive and predictive maintenance. we are talking about AI models who can anticipate failures early enough and also prescribe optimal repair actions. Third domain has to do with quality control. We translate this into anomaly detection to the data that we receive from the sensors and so on in order to spot defects instantly or at least early enough and minimizing rework, waste, scrap, and so on. And the fourth, which is connected, let's say, to the circular manufacturing concept, is whatever has to do with processes in the supply chain management. So data-driven forecasts, optimizing production schedules, and ensuring just-in-time delivery, and trimming logistic costs at the end, production and logistic costs. Now, as I said earlier, we starting facing those challenges from an academic point of view or from a research point of view. But we realized that these are actual problems, these are actual challenges, and that not all production managers are open to AI, not all project managers are open to technology. Asking why, a common response was that, okay, we get a suggestion, but we don't understand why your system proposes this and this.
The root cause.
So that's why there's a trend during the last 1 or 2 years. It's a trend that came out of the industrial partners, for going from AI to XAI, to explainable AI. So not just proposing or suggesting something, but also reveal, in a way, how the decisions were made, identify root causes, and in this way empowering the operators, the human operators who take the final decision, with real insights of why this decision, why this result, to understand why, in order to be convinced and to feel more sure that this is the correct thing to do. In general, the fact that AI can be the catalyst for shifting from linear, let's say, to secular models is something that more or less all of us agree. The thing is how to convince the main stakeholder of the supply chains and the main stakeholder of the manufacturing economy to trust us as a company, but also all of us as technology providers, although we don't have the knowledge, the deep knowledge in the domain, the problems, we're not in the production lines, but we can really offer value with really not a huge cost.
Exactly.
Okay.
And I think that...
So I don't want to spend more time, but I'm here to discuss whatever you like about this. And I hope you have the opportunity to make a nice discussion afterwards.
It's really important that I truly agree that explainable AI can address the barriers of early adoption of these technologies from the stakeholder side, and it's important to develop it and research it more in these projects. Thank you, Dimitri. And Vicky, leveraging efficient data integration on the one hand, that Pedro mentioned, and the advanced capabilities of AI, digital twins play a pivotal role in real-time decision-making and process optimization. It's also demonstrated in many projects, like Da Capo, for instance. Looking ahead, we go to cognitive twins. Professor Kiritsis also mentioned this in a previous presentation. My question is, from your experience in these European research projects, can you please share some notable examples and best practices of digital twins where they have really demonstrated their value and impact on manufacturing systems?
I think I'll just continue from what you said already. The Capo project, which I think is a very successful example of using digital twins in industry, and our use cases are from different sectors as well. So we're talking about Fairphone with their mobile apps, where the digital twin is about the battery usage optimization. So we're not just talking about manufacturing phase, but also the use phase. So that way the user can tell whether he's using the battery in the best way possible, and then moving on to GKN case, where we're trying to build this digital twin that will optimize the repair process. And here we have these circular economy principles that come into place. So we see also the part from the part for manufacturing, but trying to repair an older product. And last but not least, we have the Pesmel case, which is optimizing their logistics and trying to have the best result without using too much resources or trying to be more sustainable. So I think digital twins can serve a purpose there, as long as you have identified the indicators that you're going after, so what you're trying to serve in the use case, and identify whether it's circularity, you're after, energy consumption, carbon footprint. Once this is set, then the digital twin developer can actually provide the most, the optimal solution and implement it in industry.
Thank you very much. And I would start from what you said, that actually digital twins support a manufacturing system and any system throughout its life cycle. So this gives me the pass for the next question, Paolo, that, okay, virtual commissioning, we can say, takes it a step further, or one can say a step back to the design phase, and it's capable of validating production systems in a virtual environment before their physical implementation. So based on the active involvement of TTS in many research programs under this role, how can virtual commissioning contribute to building more efficient and resilient manufacturing systems, as demonstrated, for example, in Maestro and modular projects?
Thank you, thank you. So after Pedro's intervention, I had 5 minutes to come up with a similar biblical metaphor, and I'll choose the one of the book of Genesis. So what if God had the means to validate his creation out of mud and water before actually creating man? Maybe we would have avoided some mistakes. I was just wondering. Next time we should coordinate beforehand in order to have coordinated biblical metaphors. So, back to being serious. Virtual commissioning is a thing. We saw this morning in the presentation of virtual components, which has a lot to do with virtual commissioning, but also in the demonstration out there with Core that was setting up a new evolution of the Swiss factory manufacturing. So what do you use virtual commissioning for today? So first of all, it's a mean of early validation. You have a virtual world where you can test before the physical thing. Problem is that it's not always easy to have those models beforehand and to make them run properly. So you have a distance between what you simulate and what you then get in reality. And the project you mentioned, for instance, Maestro, not modular, the first one you mentioned, was taking care of creating behavioral models integrated in the EC 61499, so that there would be a seamless conjunction between those modules, and what they were emulating was actually what is going to be in reality, bringing the adherence of the virtual environment to the real world unparalleled. Then the second advantages of virtual commissioning is the use of enhanced collaboration. So many stakeholders can cooperate on this environment together. meaning that something that you can parallelize activities that you couldn't before. And that's Maestro. Maestro is working on an industrial metaverse where people can collaborate on actual scenarios, production scenarios, even if not a bolt is put into the ground. Then there is optimization and efficiency. So you have the behavioral models, you have the data, you stick them together and you can check different scenarios. The more adherent, it's some kind of derivative from the first two. The more you have adherent models to reality, the more you have actual data, the more those scenarios will provide you with actual means to evaluate what you're going to do. And the last one I could think of is the improved resilience. Because when you're setting up things, you have failure scenarios, you have things that go wrong, but you could be prepared because you have activities in the virtual environment that tells you what to do in case something happens for real. I would like to quote a third project, which we are working together with Core. It's called AutoTwin, because one of the main problems is the time you use in building adherent model, actual models. And within this project, we are working on process mapping so that we don't take care of building up models. We do take care of tracing elements, and then we have AI-based technologies that reconstruct the model that have been building, that as for an output, those kind of element flowing in the system. It shortens the time of building model that you can reuse for virtual commissioning quite a lot.
Exactly.
Just the last thing, within TTS we are applying some of those models, and in one of our customers working in EV carpentry construction, steel carpentry, we shortened the commissioning time from 5 weeks to 4 days, because beforehand we need to be by the customer for 5 weeks in setting up things, setting up the PLCs, checking machine or whatever. Now it's 4 days, so it's actually a mean to save costs, time and money.
Exactly, and this is what I wanted to comment, that it's not only time, it's also cost that you reduce using virtual commissioning tool. Thank you very much, Paolo. And Nikki, all the speakers so far have highlighted the benefits from digital technologies and green technologies that bring in terms of productivity and sustainability, but still the adoption of these technologies in the industry in general and the manufacturing sector seems to be slower than desirable. Based on your experience and also from projects like DigiTwin Green and Smart Tenants, which are the critical factors that slow down their adoption? What are the barriers and how can they be addressed effectively?
Okay, first of all, thank you for the question, and thank you also for the invitation to this very nice event. I'm happy to be here to contribute in the discussion, and I really enjoyed the statements of the previous speakers. I will try to bring this a little bit different dimension on the topic. So we see that there are a lot of developments and a lot of advances in technologies such as artificial intelligence, digital twin, predictive maintenance, and so forth. But as you say, we see that still we don't have the widespread adoption coming out from the industry. And I would like to bring also some numbers on the table. If we look on the Greek small medium enterprises, we see that 43% of the companies are declaring that are in basic digital states against the 57 in European manufacturing companies. And then if we look on the artificial intelligence usage in the day-to-day business of enterprises, we see that in Europe, the average is 8.8% of enterprises. So we see that there is a lot of room to support companies in the adoption. What are the barriers? 4 points I would like to highlight here. First point is, of course, that companies need to get more awareness on the benefits they can get from these technologies. And events like this one today helps companies to understand the technology and how they can get benefit of it, and then maybe get them on the next level of experimenting on how to use it.
Second point is the complexity of integrating such solutions. We see today that many companies, they don't have the needed infrastructure and the legacy systems that will help them to adopt implementations, but there are also other programs that are supporting these kind of pilot implementations. These implementations can de-risk, let's say, the investment, because they start from small pilots, small showcases that can analyze and showcase the benefits that the industry can come and then help them scale up. So as a bottom line, I think that the important thing to accelerate adoption is, of course, to stimulate the ecosystem, to work together, and using, of course, instruments coming out from European Commission to make it happen in an effective way.
Thank you.
Thank you.
Thank you very much, Nikki. I think we have already run out of time. Thank you all for your insights and this half-religious discussion, I'd say. It was very enlightening what you shared with us. And I think we can have 30 minutes for, if you have a question or a comment to our speakers, please, now it's your time. Please raise your hand in case you want to ask something. Okay, and thank you very much.
Thank you.